our channel. Today we're going to talk about linear programming using Simplex method. Simplex method is one of the most powerful and popular methods for linear programming. Simplex method is an approach to solving linear programming models by hand using slack variables, tableaus, and pivot variables as means to finding the optimal solution of an optimization problem. This is a method that achieves the best outcome given a maximum or minimum equation with linear constraints. Suppose a company manufactures different electronic components for computers. Component A requires 2 hours of fabrication and 1 hour of assembly. Component B requires 3 hours of fabrication and 1 hour of assembly. And component C requires 2 hours of fabrication and 2 hours of assembly. The company has 1,000 labor hours for fabrication and 800 labor hours for assembly time each week. If the profit on each component A, B, and C is $7, $8, and $10 respectively, how much of each should be produced to maximize profit? So we know that this is a maximization problem. The objective function is maximize profit Z equals to 7x1 plus 8x2 plus 10x3, subject to 2x1 plus 3x2 plus 2x3 less than or equal to 1,000. x1 plus x2 plus 2x3 less than or equal to 800, and x1, x2, x3 is greater than or equal to 0. We let x1 be the number of components of type A, x2 the number of components of type B, and x3 the number of components of type C. 7, 8, and 10 are the profit of each component. The first constraint is for the fabrication. It takes 2 hours to make type A, 3 hours to make type B, and 2 hours to make type C, with a total of 1,000 labor hours. The second constraint, it takes 1 hour to make type A, 1 hour to make type B, and 2 hours to make type C, with a total labor hours of 800. And x1, x2, and x3 should be greater than 0.
First thing I'm gonna do is to take my objective function and constraints. What I'm gonna do, I'm gonna add these new variables, the slack variables s sub 1 and s sub 2. The idea here is to transform our inequalities and make it into an equation. From this, we can now produce our simplex W. For our first W, as you can see, the variables under x1, x2, x3, s1, and s2 corresponds to the constraints and slack coefficient values, and Cj is the cost associated with the basic variables, the cost associated with s1 and s2. Solution mix is equal basis, in which we have put the basic variables, and the quantity is the initial basic feasible solution or optimal solution. Zj is Cj multiplied by our basic variables, or the coefficient values over variables. Zj for x1 is 0 times 2 plus 0 times 1 is equal to 0. In the same way, all values for Zj is 0 plus 0 times 1 is equal to 0. Now for the Cj minus Zj, 7 minus 0 is equal to 7, 8 minus 0 is equal to 8. Since this is a maximization problem, all the values of Cj minus Zj should be less than or equal to 0. And lastly, 0. But in this case, the results didn't show, so we can say that our optimal. For our entering variable, we need to see the most positive Cj minus Zj. Now we need to find the entering variable and the leaving variable. So we say that x3 is our entering variable and it serves as our pivot column. In our case, that is 10, and it corresponds to the variable x3. To determine the leaving variable, we need to find the smallest value of quantity upon x3. Now we need to determine the leaving variable. So 1000 upon 2, 800 upon 2, The intersection of our pivot column and pivot row serve as our pivot number, which is S2. So S2 serve as our leaving variable, and that is our pivot row. Now you can see that X3 has entered the basis, and S2 has left the basis, and leaving variable, we have constructed our second tableau.
This is the second tableau that we solved earlier. So what we will do next is we will compute new values for the pivot row. Using steps 3 and 4, we were now able to obtain the pivot number, which is 2. Finally, we will be computing for the new values for the new pivot row. So we will divide each number from the pivot row to the pivot number. After dividing, we now have our values for the new pivot row that will be used for the third tableau. So what we will do now is we will compute for the new values for each remaining row. The formula will be number in old row minus number below or above pivot number multiplied by the corresponding number in the new pivot row. This is how it will look like after computing for each. As you can see in the X2 and X3 row, these are the values that we have computed earlier. This is how tableau number 3 will look like. So for row X2 and X3, we have already obtained the value. Now we will compute for this ZJ and CJ minus ZJ rows. So ZJ would be equal to the gross profit, so the formula would be profit per unit of row 1 multiplied the number of units of row 1 plus profit per unit of row 2 multiplied the number of units of row 2. So we will compute first for column X1, so it would be 8 times 0.5 plus 10 times 0.25. It will give us an answer of 6. For column X2, 8 times 1 plus 10 times 0 would be equal to 8, and so on. Now we compute for CJ minus ZJ. So what we meant by CJ isn't the CJ column, but what we meant was CJ row. So CJ for X1 is 7, X2 is 8, X3 is 10, and S1 is 0, and S2 is 0. Negative CJ minus DJ number means profit will decrease. An optimal solution will be reached if there are no positive numbers in the CJ minus ZJ row. If you look at the result for CJ minus ZJ row, there is still one positive value. This means that we still haven't reached the optimal solution. Since we were not yet able to get the optimal solution for tableau number 3, we repeat steps 3 to 7 for tableau number 4. After repeating the steps, this is how it will look like for tableau number 4. Highlighting CJ minus ZJ row, the values are 0, negative 1, 0, negative 2, negative 3. So as we can see, there is no positive value. This means that we have reached the optimal solution. So the optimal solution is x1 is equal to 200, x2 is equal to 0, and x3 is equal to 300. And the optimal solution is z is equal to 4,400. So we will insert the values to check if our answers are correct. So 7 times 200 plus 0 plus 10 times 300 plus 0 plus 0. 1,400 plus 3,000 would give an answer of 4,400. So the optimal solution is 4,400.
That's all for this video. Thank you so much for watching. Don't forget to like and subscribe. Till next time!